This is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 8-4 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to model vertical motion. So in this problem, we're looking at a diver who's jumping off of a high platform with an initial speed or initial velocity of 16 feet per second. Now understand this is the initial vertical velocity, so that means straight up. Now understand this is a concept called vectors, alright, which they deal with a lot in physics. The vertical velocity of this person traveling does not affect their horizontal velocity. Alright, so how much they're going up here is not affecting how much they go to the side. Alright? So we are just looking at the height version of things. We are not looking at how much force he put going forward. Okay? So it says, what quadratic function represents the height of the diver t seconds after the dive? Alright, so what I'm going to be doing is using what's called the vertical motion model to write a quadratic equation. So here's what the model looks like. So it says the height over time is equal to negative 16 t squared plus v naught is how we say that. This means the initial velocity times time plus h naught, which is the initial height. Alright, so if I can find the initial vertical velocity and the initial height, I could plug it into this formula and get my expression. Okay? So the v naught, the initial velocity, they give us as 16 feet per second. So I'm going to go ahead and plug in a 16 where the v naught is. For clarity's sake, I'm going to go ahead and highlight those. There we go. And then I add to it my h naught, which is my initial height. So this is where I'm relying on their image, their picture. You could see the height of the platform is 30 feet. So I'm adding the 30 here. And highlighting for clarity. Alright, so there is my expression. Now part B is asking us to go ahead and use this information to help us to figure out where he's going to be at the highest point of his dive. So when he jumps up in the air, how high up does he get? Okay. Now for this, what we need to remember is our formula to find a vertex. Okay, remember, first thing that we do is we find our axis of symmetry using the formula x equals negative b over 2a. And then once I know where that axis of symmetry is, I'll go ahead and I'll plug it in to find my vertex. Okay? So let's start with that axis of symmetry. So I have x equals negative, my b value in this case is 16, over 2 times a, which is also negative 16. So the negative 16 and negative 16 here actually cancel each other out, leaving me with 1 over 2. So that is the x value of my vertex. And we'll talk about what that means here in just a second. In this case, it's the t value. Alright, so now that I know that 1/2, now I'm going to find h of 1/2. So I have negative 16 times 1/2 squared plus 16 times 1/2 plus 30. So 1/2 squared is 1/4, and 1/4 of negative 16 is negative 4. 16 times 1/2 is 8. And so if I add negative 4, 8, and 30, I get 34. Alright, so at 1/2 second, right, because our x value that I used here, I really should have called it a t, is talking about our time. So in 1/2 second, he's 34 feet in the air. And so that is the maximum height. So it says, find the maximum height above the water if he dives from a 20-foot platform with an initial velocity of 8 feet per second. All right, so they're cutting the platform down by 10. So he's probably chilling over here on this one. And he's jumping up a lot slower. His initial velocity is half of what it was. So my formula in this case would be negative 16t squared plus 8t plus 20. All right, so that's a much smaller equation. Okay, so again, I'm going to find my axis of symmetry and then use that to find my vertex. So for my axis of symmetry, I'm using x equals negative b over 2a. Remember, this is really t, but I hate changing my letters in my formula. So negative b, so negative 8 over 2 times a, which is negative 16. And so the negatives cancel out, and the 8 and the 16 cancel out, leaving a 2 in the bottom. So that gives me 1/4 for my axis of symmetry x value, or t value. And so now I'm going to go and plug 1/4 into my function and figure out the maximum height. So I'm finding h of 1/4. Okay, so here I've plugged 1/4 into the equation. So 1/4 squared is 16, or sorry, 1/16. Times negative 16 gives me just a negative 1 here. 8 times 1/4 is 2. So my height in 1/4 of a second would be 21 feet. And so the maximum height in this case. So notice his slower velocity didn't take it as far above the platform, right? Because the platform for this one was originally at 20 feet and he only went an extra 1 foot. Whereas on this one, when he did a greater initial velocity, he went up 4 feet above his platform. So that's kind of interesting. Just making sure that was the end. Good. So there we are, guys. That was how to model vertical motion. Until next time.